So this video provides answers and explanations to the MCQs related to thermal properties of matter that include specific heat capacity, thermal expansion, and all related topics. So first question, although not included in your curriculum syllabus, these are two thermometers. Thermometers are identical except that Q has a capillary tube which is large with large internal diameter than P. So which thermometer will have the large range and thermometer has a greater sensitivity? Q will have the large range and P will have the greater sensitivity. It is because this will be able to hold more temperature increase because of the diameter of the capillary tube, and this will give you a very fine rise or a small change in temperature. This question, which substance is liquid? So any liquid at 20 must have a melting point below 20. B has this. And boiling point above 20. So we talk about the liquid, so only this will suffice. Don't worry about the boiling point. Heater is placed, heater is on. What happens to the liquid at X? It becomes less dense and rise. So all the data is given, specific latent heat, although not included in your syllabus. So the heat lost by the warm water should be equal to the heat gained by the ice. Heat lost is calculated by specific heat capacity, and heat gained is given by ml, the latent heat formula. So calculating L will give this choice. So I think the choice given is wrong. So we will have this choice B. Heat capacity of an object of mass is C. The energy needed to increase the temperature of the whole object by T is T times delta T. So here it is the heat capacity. It is not specific heat capacity. So mass is not required in heat capacity. The electric heater. So all the data, we have temperature, we have energy, and the heats it to this much. So 20 degree is the change in temperature. The specific heat capacity is given. Mass will be total heat 6,000 divide specific heat capacity 4,200 divide 20. If you do the calculation, you should get this answer. And the explanation is actually given here at the top. So the latent heat of vaporization, you should know the definition. It is the energy required to vaporize, make the molecules move apart. And we have to calculate the amount of the water that is added. So again, this numerical is not in our syllabus, but we will look at it. So again, the amount of heat required is calculated, and then it is equated to the latent heat. So the latent heat is calculated using this, and this gives the mass 120 grams. What is happening at X? Well, the liquid is solidifying to become solid. And also it is evaporation. Evaporation is also taking place. So in this one, why? Well, obviously we know that it can't be these two because there's a linear increase in the temperature and linear increase in volume when the temperature increases. But why not zero? Because volume can't be zero according to Charles' law. So at zero, the volume won't be zero. It becomes zero at zero for only for ideal gases. So nothing can have a zero volume except ideal gases, and ideal gases don't actually exist. Thermal energy transferred to solid, it melts and then boils. Which statement of temperature? When melting and boiling, temperatures do not change. We know that very well. So we have steam at 100 passed into some water in beaker. Steam condenses in the water. The mass is given and rises to this much. Latent heat of vaporization is given. So how much thermal energy is lost by the steam? Well, first of all, the mass is 2 grams. So put this in the latent heat formula. That gives you the energy. (200 gram water, 100 converted to 100 in steam in 300 seconds. And this gives us the specific latent heat is this much. So putting the value of specific latent heat and gives you the energy. So 200 multiply the energy and divided with the time gives you the power. So we have here the energy for 2 kg mass of the copper and its specific heat capacity is this much. The rise in temperature, put in the values, calculate the change in temperature, comes out 15. So there is no change in pressure because of this statement. The piston can move easily. When you heat it up, the volume will increase, pushing the piston, which will move up. So pressure will remain the same, volume will increase. So we just multiply this to get the biggest answer. 200. So it is because of the decimal. So 0.1 of 200 will be 20, 0.2 of 200 will be 40. That means for the minimum possible heat, we are having the maximum increase in the temperature. Minimum mass gives you the minimum mass of a substance taking this energy will give the greatest temperature change. And the reason for this is the temperature rise is proportional to 1 over m into c. So the block with the smallest specific heat capacity or smallest mass will experience the greatest. Look at these two variables. So here we have the mass. So that's why smaller the mass is, the higher the temperature changes. Latent heat is released in this point, in this part of the curve, because this is where the line is flat, no heat is coming out, and the heat, the temperature is cooling down, so the bonds are being made, so the heat is actually absorbed as the time passes. So the temperature does not fall down. Gas expands most, solid expands least. Ice at -10 changes to +10, so this is not possible. Is heated until it is water at 10. So sorry, this is possible, or this is the only possible thing, because when you heat the ice, temperature increases, becomes liquid, and then temperature increases. Heated from -10 to 10. Heated from -1 to 1, not possible. Heated from -10 to 10, but at 10 it starts to change into water, and this is a curve that is not heating curve. So the heating curve here is the right choice. It is because copper has lower specific heat capacity. That's why it needs less heat. It is because the metal lid expands and it gets open. You can try this. Putting all the values in the latent heat diffusion formula, energy will be M times L, 3000. Not included in our syllabus. Don't worry if you don't understand. So, INVAR has more strip is made from two metals. Diagram shows the strip room temperature after it's been cooled. Room temperature after it's cooled. So that means that the broth has expanded. The INVAR has remained in place. So the choice seems wrong. The choice will be A. It is the broth that contracts more. So how much ice pack extract? How much heat is extracted? It will be calculated using this. The heat energy that, so here the ice pack becomes the source of the heat that is taken from the water. So its specific heat capacity and the heat will be from here. So we will calculate its heat, its mass is given, its specific heat is given, and the temperature, it has gone from 15. So it has decreased the temperature of water from 15. So the temperature of water, sorry, we got it wrong. It is the water whose mass, the specific heat, and whose temperature has increased. So this is how much heat that the water has absorbed. So this is how much heat the ice pack has given to the water. Teeth should be made from something that expands the same amount as tooth, otherwise it will fall down when it's cooled. So specific heat capacity, small c needs calculating, rearrange the formula, put the values and get the answer. So melting and boiling require energy input. Freezing and condensation requires releasing of the energy. So 1 and 2 take in energy, 3 and 4 give energy. First, we will calculate the amount of energy getting in. Then we calculate the time using the energy power relationship, 2000 seconds. This question now with a different statement. So the brass expands more than iron, so it will take over. Iron has expanded less, brass expands more, it will take over. It will be bending like this trick. Process of solidification and evaporation at up. So when it is thermal expansion of a solid, of a substance, it is air that is expanding above a Bunsen burner. Why these are wrong? Decrease in the resistance is not expansion. Rise in pressure is not expansion. Blowing of fuse is melting. It's not expansion. So latent heat of vaporization is linked to breaking of the bonds. So only A and B should be considered. And then molecules escape because of the vaporization. This is not vaporization. This is vaporization. Rise in temperature by putting the values in the specific heat capacity expression. Put the values and this is the answer. So why we have these gaps? It allows the thermal expansion. So the lines do not bend. They allow the lines to remain straight during heat, which is the heat. Hot liquid, same thing as side silver, reflect heat back, hot liquid remains hot. So heat doesn't mean the heat, it can be cold as well. So the cold coming from outside will be reflected, hot liquid will remain hot. Heat capacity is the quantity of heat required to raise the temperature of an object by 1 kg. It doesn't include mass. So 1 kg shouldn't be considered. These two are wrong anyway. Again, repeat question. So here we have a mercury pellet and a buzzer. It is an alarm and it's a smoke alarm, fire alarm. When mercury pellet moves, here completes the circuit. Why this happens? Because the temperature rises and the gas expands, pushes the mercury pellet. Mercury pellet doesn't expand. It is just pushed by the gas because of the heat. And it goes here. Mercury is the conductor. So it makes the circuit complete. The buzzer alarm. Temperature corresponds to C. 0 is this one. So this is where the solid is becoming liquid. The energy required to change liquid water to liquid vapor increases the average separation. It doesn't increase the temperature and average speed, which is also the temperature. and this is not valid anywhere. So here, all the data is given, the power of the cathode, the time, the energy, and the mass. Specific latent heat, Q over M. So Q is equal to MC specific latent heat. So specific latent heat is equal to Q over M. Put this value, get this out. Specific heat capacity is calculated, putting all the data in here, comes out 130. Repeat question. Temperature of paraffin rises because it has smaller specific heat capacity. And here, again, the same question with a different curve. So it will be from -10 to 10. Others are discussed previously. So a glass jug is designed so that it doesn't break during boiling water is poured into it. It has to have thin thickness and it should expand greatly when heated. Yes, it should expand greatly when heated. And if the thickness is thick, then one side of the glass will expand while the other side will still be colder. So its expansion from one side will make it bend over and that will break the glass. So it has to be thin. The axle is too large. So we pull the axle, it contracts, it passes through it. The rise in temperature requires calculating mass given, time given, power given, specific heat capacity given. Put all the values. And then once you got the mass, you can calculate the change in temperature by this. So the power, the energy you will get is from the power relationship. You will multiply the power with time to get the energy to put in this Q. Thank you.